So we've done the stretching, so how about a game now? How many of you are familiar with the game Never Have I Ever? Can I see the show of hands? All right, a lot of people, most of you. So it's pretty simple. I will make a statement, and if this has happened to you before, please raise your hand. Never have I ever prioritized new feature development over addressing technical tech debt. All right, many hands, yes. How about this one? Never have I ever had to reprioritize projects due to sudden changes to leadership directives. Yeah, we've all felt that pain, right? This one, the last one, is my favorite. Never have I ever launched a product or feature only to deprecate it a few months later. Yeah, me too. So, all of these, each one of these is an outcome of a decision that was made. And we all make decisions. And as Mary just said, regardless of what level you are, whether you are an individual contributor or a manager, you make decisions. It doesn't matter if you're an entry-level software engineer or a staff plus engineer leading cross-functional projects. You constantly make decisions that shape your projects or teams. It could be deciding on a database solution or training a machine learning model, what type of machine learning model to train, or maybe hiring someone, or deciding to put somebody in a performance improvement plan. Every choice you make has a ripple effect. It impacts your work, the value you create, the culture you foster, and it also affects everyone around you, in your team and organization. And as you move up the ladder, your influence and ownership over these decisions grow exponentially. If you're a leader in your organization, you might be thinking, well, I don't want to be the one making the decision, I want my team to own the decision. And even if that's the case, although most of the times we have to step in and make tough calls, even if that's the case, you still need to guide your team towards the best possible outcome. So in this talk, I want to share with you some strategies for making decisions that can maximize your return on investment, whether you are the one making the call or helping your team reach the best possible outcome. My name is Katerina, and I'm currently a senior machine learning engineer at Meta. I have been working as an individual contributor for almost 10 years now, and through my career, I have held many different positions. Obviously, I've been the most junior person on the team, and I have also been the team lead. And over the years, I have made my fair share of technical decisions. Some of I'm really proud of, and others I wish I could have done differently should I be given the chance. And I don't know if you caught that in the intro, but besides my computer science and engineering background, I also have a degree in journalism. Yes, I am a trained journalist. It's not a lie. And even though this might seem very unrelated to being a software engineer, it has actually helped me a lot throughout my career. It's taught me to think critically about the choices I was making, and it also helped me see, as journalists say, the story behind decisions. So today, I would like to share with you 2 stories from my career where I made a decision and the impact it had. In the first story, I had to design a solution for tackling a cold start personalization problem in our team. I had full autonomy, and so I decided to go with this state-of-the-art machine learning model that was launched recently in our company, but for a different product. And I was very excited to learn about this new model, and especially because the results it showed in this other product seemed very promising for our use case too. So I documented my hypothesis, and I explained why I thought this model was a good solution to our problem. It was just me and one other engineer from the team that were working on this project. And as it happens, there were some known risks and some unexpected ones. For starters, we actually didn't know that the features that we needed to train the model were not available. So we had to establish a collaboration with a team that was responsible for the features generation. Additionally, neither me or the other engineer on the team were really familiar with the model itself or the framework it was developed on. But what made this worse was what we didn't know, which was that the team that developed the model in the first place had no bandwidth to support further adoption of the model by other teams. And as a result, we had to figure a lot of things on our own. We got the features and trained the model, but because we had to work with this other team and coordinate, this took additional time. And the fact that we had to go, and in depth into the model and really understand how it works, so that we can be sure that it trains correctly, also pushed our timeline. And as our timeline extended, the other engineer felt a little bit unsure about the project itself and its progress, so he decided to fully commit to this other project in our team, leaving me to handle this one alone. In the end, I trained the model, I set it up in production, and I ran A/B tests to measure its impact. And the results showed little to no impact, which basically meant that there was no real reason to launch it to real users. I had spent an entire half of the year working on something that brought zero value to my team. The silver lining in all this was that I learned a lot from this project, and the skills that I acquired proved invaluable for future projects I worked on. Now, in my second story, I was the tech lead of a core internal platform in the company I was working for. When I took on this role, I had big dreams and aspiration of building new features in the platform and taking it to the next level. But I bet you know where this is going, right? Well, as it turns out, the platform had a lot of tech debt, and we were actually putting out fires almost every other week. Being on call was a nightmare. And as a plus, my team actually didn't have a lot of know-how about how the platform was built originally, because they weren't the ones who built it in the first place. And a lot of that was lost when the engineers who built it originally left the company. And to make things worse, a new company priority caused the request load on the platform to skyrocket over a few months, and we were told about this late. We went from handling 100,000 requests per second to needing to handle millions. Our platform started struggling to meet SLAs, and it was clear we needed to scale up quickly. So at that point, given the constant fires and struggle to meet our customers' demands, the product owner suggested to leadership that we should replace the platform with a vendor solution. So what did we do? I decided to evaluate our options, and after gathering data and considering our requirements, I actually showed to our leadership team that switching to a vendor wasn't a good idea. It would introduce a lot of overhead because we would have to maintain the existing platform and migrate to the new one. Instead, I got the team together and we came up with a plan to scale our systems to handle the increasing load. We worked really, really hard, and we managed to keep the platform running and support the increasing load and meet our SLAs. However, of course, in order to do this, we had to use a lot more cloud resources, which led to increased costs for the company. And after all this, even though this whole operation was successful, I felt completely drained and burned out, so I decided to switch teams. So now I told you both of my stories, and I want to ask you a question. How many of you do you think that actually going with a high-risk machine learning solution in the first story was a good decision? Can you please raise your hand? One hand, okay, very few hands, all right. How many do you think it was a bad decision? No one? Or you're just unsure? Yeah, okay. Well, that's the right answer too, because, as we love to say in software engineering, it depends, Yes. When we make decisions, we all subconsciously think about optimizing return on investment, or ROI. ROI is basically the gain from making the decision to do something minus the cost of that decision. Pretty straightforward, right? But here's the catch. We all define gain and cost differently in our minds when thinking about ROI. And while for most of us it's usually time or money, or time and money, gain is much more ambiguous. How would you define gain for what you're currently working on? Could it be the number of lines of code your team commits? I hope not. Is it just getting the project launched? Or is it launching and it's seeing a positive impact? Maybe it's saving the company money by deprecating a costly legacy system, or the adoption rate of a new feature. And do you think the way you define gain for your decision is the same as how your team defines it? How about your manager? There can be great misalignment here, right? It highly depends on the context you have and how you interpret it when making a decision. The other factor that affects ROI in decision-making is the biases we all bring to the table. I wanted to learn about the cool state-of-the-art machine learning model, and that had been launched at the company, if you remember, and that affected my decision to make it my whole project for the half. And in my second story, when the vendor solution was proposed as an alternative, I was quick to defend our in-house platform because of the work that me and my team had put into maintaining it. Bias could take many other forms. It could be that you want to work with specific people, or perhaps you're pushing to launch something because it will look good for a promotion. And bias could make us overlook the actual costs of our decisions, making the potential gains seem more important than they really are. So how can we make decisions that truly optimize our return on investment in a way that's more objective and beneficial, not just for ourselves, but for our teams and organization? From my experience, there are 5 main factors that heavily influence the return on investment when making technical decisions. These are potential, risks, involvement, skills, and motivation. So let's look at each one of these to see how they can affect our decision-making process. Potential is all about understanding the impact and benefits of our decisions. It's about the business. It's about the value we create. To assess potential, ask yourself, how will this decision improve user interaction with our product? Can this decision drive higher sales or increase customer retention? Will it streamline processes and reduce costs? Does it support the broader objectives of the company? When evaluating potential impact, try to measure it rather than making vague estimates. Use direct metrics to answer these questions I just asked. For example, if you're optimizing a database solution for your project, consider operational metrics. Could it optimize your workflow and processes? Measure that in terms of developer time saved when implementing new features. If you're evaluating which machine learning model to use, look at the impact it had in other applications. And this could be like what was reported in research papers, or maybe from use in company products. For higher level decisions, like which project to work on this half or what problem your team should solve, use metrics that align with your organization's strategic goals. And sometimes this is straightforward. If your company needs to cut costs, then you identify which systems are expensive and maybe you deprecate them or optimize them. And you assess how much that could contribute to the cost-saving goal. But other times, it's much more complex. For instance, if you're optimizing for user engagement or you need to increase conversion or adoption rates, it might not be easy to make a strong argument for the potential of your decision. In those cases, mapping the potential of low-level decisions can actually help assess the potential of higher-level ones. And if it's still not possible to show how your decision is serving those top-line goals, think about proxy metrics. Can you spot correlations between your goal metrics and other easier-to-measure metrics? Then you can use the easier-to-measure proxy metrics to support the decision of your top-line goals. Measure the potential impact before settling on a decision. So once you have assessed the potential, it's time to identify the risks. This means looking at all the limitations and constraints around your choices. Are there any technical challenges that might hinder your decision's success? Do you have enough resources and budget to support your decision? Will you be able to meet required SLAs? Are you handling any data that requires adhering to necessary privacy and security regulations? In my story about considering a vendor to replace our in-house platform, the fact that the platform handled user data played a big role in deciding not to outsource. And just like potential, you should measure risks. Establish guardrail metrics that can set the boundaries of your decisions. This could include system performance metrics such as system reliability, uptime, and system response time. It could also be listing the system's exposure points if these are public endpoints that could be subject to security threats. Measure how sensitive your data is, and if your decision is relying on it, maybe you would need to have in place processes to delete it if requested. Ensure the data you rely on will continue to be supported. And of course, the one that I bet most of us are thinking about, do we have the resources and the money to support our decision? All right, we talked about potential and risks, which you're probably already considering when making technical decisions. But I bet you're not really thinking about the next one. Involvement. Involvement is about figuring out who needs to support your decision to make it successful. First, you need to identify your partners. And once you identify them, think about what would motivate them to invest in your decision. Understanding their motivations helps secure their commitment. Could sharing credit with them once the project is done be a motivator? Or will the outcome of your decision positively impact their work? What's in it for them? When you establish a partnership, the work is not done. Can you collaborate effectively? What processes need to be in place to ensure a smooth collaboration? Can you set up clear communication channels and regular check-ins to help maintain alignment? The other component of involvement is recognizing dependencies with other teams. In my story about developing the state-of-the-art machine learning model, I had to address our dependency on the team responsible for the features generation. And we needed to coordinate efforts and resources with them in order to make progress. So, do the teams you depend on have the bandwidth to support you? In my case, I had miscalculated the infra's team's availability to help us, which meant I had to figure out a lot on my own. So considering all possible dependencies with external partners can help you anticipate bottlenecks or conflicts and set realistic milestones and deadlines. Or you might recognize that your decision isn't feasible due to too many dependencies. Okay, so far we looked at the external factors of decision-making. Now let's turn inward. Can you or your team actually execute on your decision? Do you have the necessary skills and expertise? This part of decision-making framework includes both technical and domain-specific skills. In both of my stories, skills were a major challenge. When developing the machine learning solution, I had little knowledge about the underlying technology and the framework it was built on. As the tech lead of the in-house platform, my team and I had significant gaps in domain-specific knowledge. If there are gaps in your skills, what do you need to learn or set up to be able to bridge them? Consider, how much time will it take to acquire the necessary skills? How many team members need to become experts in specific areas? How easy is it to hire someone who has the necessary skills and expertise? The challenge with skills as a factor in decision-making is that it can be highly aspirational. We all know, probably, this engineer, or this engineer could be us, who overestimated their ability to quickly master a new area, only to find it took much longer to be productive. So, if you're considering overlooking a skills gap for a project, think about how efficient is your team at completing tasks on time? What is your velocity? How excited is your team to learn a new skill? Do you have the resources and bandwidth to learn it? In this conference, we talk a lot about how we should cultivate a culture that supports learning new things, and this is absolutely true. But we should also recognize that sometimes it's more productive to leverage your existing skill set and minimize the need for new training. However, if you never push to try something new, you might miss opportunities for your team to grow. Which brings us to the last part of our framework, motivation. Motivation captures how committed and excited your team is about the decision. Unfortunately, motivation is often overlooked in technical decisions, even though a motivated team, as you might know, is more likely to be engaged and perform better. So think about how much your team will grow from the initiative you proposed. Projects that offer learning opportunities and skill development can really boost motivation. And other times, it's all about being able to have a certain type of impact. Gauge their excitement and motivation. If it's not aligned with your priorities, work together to find common ground. And sometimes we have to make decisions that don't fully align with our team's aspirations. In these cases, it's crucial to understand the potential effects on morale, as it can impact productivity and even lead to higher turnover. One-on-ones and regular check-ins are great and effective tools to get direct feedback from team members to understand their level of motivation and any concerns they might have. Ask them direct questions about what decisions are important to them and ensure there is alignment with the decisions made and your team's career growth goals. And another tool is to use regular anonymous surveys to get async feedback, as the previous talk also mentioned, to provide insights into how satisfied and motivated your team feels. All right, I have 3 minutes left, so now let's put them all together. Remember how we were optimizing for return on investment? So, in the context of the ROI formula, consider potential motivation and skills as the elements that contribute to the gain from your investment. These components drive the benefits and positive outcomes of your decisions. At the same time, risks and involvement represent the costs you need to manage. If not properly addressed, these factors can really impact the effectiveness of your investments. By maximizing potential, motivation, and skills, while minimizing risks and balancing involvement, you can ensure your decisions are both impactful and cost-effective. In the end, remember that there is no single right decision. The right decision is the one that best fits your unique circumstances and objectives, maximizing your return on investment. The decision-making framework I shared with you today helps you break down what contributes to your gains and what adds to your costs. Making smart technical decisions is all about finding the right balance. In your own context, you can decide how to calibrate potential, skills, and motivation as your gains, and risks and involvement as your costs. This approach can help reduce bias and give you confidence in your decisions. And don't forget, it's not just about the technology or the numbers, it's about the people, the collaboration, and the strategic thinking that goes into each choice. So keep these 5 factors in mind, and you will be well on your way to navigate the complexities in decision-making. Thank you very much.